So in this tutorial, we're going to learn how to use the NPER, or number of periods function. So with this function, there are four main arguments: rate, payment, present value, future value, and then an optional type. And type, like before, is going to indicate whether the payment's occurring at the beginning or at the end. By default, the payment occurs at the end, but we'll see in our first example we start at the beginning. So our first example is right here. You started with 100,000 and today you have 175,000 in savings. That was earning an average return of 10% compounding annually. How long did it take to grow your savings? So our growth rate is 10%. We've contributed 0 payments. It was just an initial deposit of 100,000, and then we have 175 today. There's no sub periods, so we've left n as none, or we can leave it as 0. The present value, we started out with 100,000, and our future value is 175,000. So let's calculate. So we're going to hit equal sign, n period. Now we can just hit tab to autocomplete. So we'll select our rate in C18. Our payment is 0, so we'll select C19. Our present value is given in C21. And one of these cash flows we should put as negative. So we'll type as C21 as a negative cash flow to indicate that we gave the bank or whatever institution's holding our money $100,000 in the past. Our future value is in C22, which is the 175,000. Lastly, we started with 100,000, so that money was actually at the beginning of the period, not at the end of the period. So here we need to enter a 1. So it took us 5.87 years. Now we can test to make sure that that's the actual amount by using the future value function. We'll do so by using the function FV. We'll select rate, C18, number of periods in E18, our payment is 0, our present value, and of course our payment was at the beginning of the period. And so our test should result in a value of 175,000 if we did this correctly. And there we go. So we can see that yes, using NPER, or the type of 1, so in our function here, typing in 1 was the correct solution. If we had hit 0, we would only end up with different response, but we're fine there. Okay. So let's move on to the second part. You want to save to buy a house that costs $250,000, and you'll need to have a 10% down payment, which is $25,000. If you can save $400 every month and your savings account earns 5% compounded monthly, how long will it take you to save for the down payment? So note here, because we're putting in money monthly, our output is going to be in terms of months, so we're going to need to convert from months to years at some point. But we'll start off by using our n period function. We'll select the rate in C28. Now notice this 5% is monthly, so we need to then divide it by the number of months, because Excel is not going to know that we're referring to 5% monthly. So all our periods have to be scaled. Our payment is going to be $400 monthly. Now, if we had received $4,800, we would then have to divide that by 12. But right now we have $400 monthly, and so we can use that amount. Our present value is 0, so we'll say C31. And our future value is going to be the 25,000. Now the money is being paid at the end of every month, so we'll put in 0. And we can see it's going to take us 72 months. Now, really quick, we're starting out here with a negative, so we could indicate that this is a negative, and then we'll change the sign. Or we can do it at the end. The other way that we can also do this, so that we get that correct solution, is to come back to our payment at C29 and type in a negative there. And so what you'll see happen is the $400 is a cash outflow. So we're giving it to the bank, and then the bank now takes possession of that money. So you can see we end up with 55.662 months. But remember, at 55 months, we still haven't earned enough money. It's that last 0.6 that matters. So what we're going to do now is we're going to use the round up function. So we're going to hit equal sign round, and then select round up. We're going to select our 55 months and then our number of digits. We don't want any digits to the right of the decimal place, so we'll hit 0. And so it rounds up to 56. And then lastly, when we want to figure out how many years it takes, we'll take our months, divide by 12. And so it's going to take us 4.67 years to save the $25,000.